Hi. Okay, if you are not understand in the previous video about asymptote, and this video I'm going to explain to you again about the finding the asymptotes of a function and using the asymptotes to sketching a graph. Alright, for this case, we're going to introduce two types of asymptote, which is the vertical asymptotes and the horizontal asymptotes. Alright, so you have, okay, let's consider vertical asymptotes. Alright, vertical asymptote. So in this case, it's a rational function, right? It's a rational function. So to consider vertical asymptote, usually we look at the denominator, the function at the denominator, where for this case it's a quadratic. But whatever happened here, if this is a rational function, this function will be undefined if and only if the denominator is approaching is 0, alright, is 0. So it cannot have 0. If you have 0, you won't have output. Alright, so it means that x squared minus 4, right? X squared minus 4 cannot be 0, right? It cannot be 0. So it means that x minus 2, okay, I just equate this x plus 2, so it's equals to 0, right? So just assume that this is equals to 0. So then we know that x is equals to 2 and x equals to negative 2. Means that x squared minus 4 will be equal to 0 if these two values happen, right? So which x cannot take negative 2, x cannot take 2. Cannot take 2. But it can be accept any value. Can accept any value, you can choose any value beside these two values. Because if you choose this value, your denominator will become 0, right? You will divide a number by a 0, which is impossible to happen in mathematics. Alright, that's why we say undefined, right? So now, okay, so means that we consider for x equals to 2. So we want to verify that this is a limit. So if this is a limit, it will be approaching infinity. If this is an asymptote, vertical asymptote, these limits were approaching infinity. So means the limit that I mentioned here is the limit to the right of this. So you will have 4x over with x squared minus 4. Right? You can evaluate intuitively. So as you know that this is we just assume that this is a 2, right? It's an exact 2. So you put 2 here, you have 4, 2, 8. You're getting a number, right? You're getting a number. So when you put 2 here, 2 square minus 4. 4 minus 4, you're getting 0. It's a number divided by, it's a limit of a case with number divided by 0. This type of case, the limits of this function will be getting infinity. So the problem here, what is the sign? Is going positive big value or negative very big value? We don't know. So we have to, using this, what they require here. So this one, you just put 2 here, 4, 2, you have 8. Remember, intuitively, in our mind, you know that 4 times 2 is 8. 8 is a positive number, right? It's a positive number, okay, in our mind. So 2, you put here, you get 0. You cannot decide positive or negative, right? Because you put 2 here, you cannot decide positive or negative. So you choose a number near to 2, but 2 plus means to the right, more than 2. So we can choose 2.1, 2.2, but very hard to think, right? So we choose 3. Can we choose 3? We choose 3, more than 2. So you have 3, means that I assume x to be 3. 3 square. 3 square is 9, right? 9 minus 4, you're getting 5. It's a positive number. So positive and positive, you're getting positive infinity. Okay, hold on first. This is a technique, right? This is a technique. So now, let's say I calculate limit as x approaching 2 from the left. Okay, from the left. So means 4x over with x power of 2 minus 4, right? So now from the left, so as I know that, I'm not going to repeat this one. It's the same thing. If you put 2 here, you get 8. It's a number. It's a number. You put 2 here, you're getting a 0. A case where the limits, when you substitute this value inside here, intuitively, you're getting a number, you're getting a 0 on the denominator. Definitely the limits, you are getting infinity. Getting infinity. But positive or negative, we have to decide. So you put 2 here, 4 to 8, this one positive, right? But this one you substitute, you're getting 0, right? So you don't put 2. You put a value of 2, which is to the left of 2. Slightly to the left, means a very small number to the left. 1.9, 1.99, 1.8, alright? So easier for you, you were choosing 1, alright? 1 less than 2, right? So 1 minus 4, 1 square minus 4, you're getting negative 3, which is a negative number, alright? So positive, negative, you have negative infinity, alright? So this has confirmed that x equals to 2 is a vertical asymptote. So mean x equals to 2 is vertical asymptote. But x equals to negative 2 also is a vertical asymptote. If we look at this, because this one 0, it will giving you a vertical asymptote. But we want to verify, right? We want to verify. We want to show for x equals to negative 2, right? Negative 2. So limit as x approaching negative 2 from the right. Check from the right and from the left, right? From the right and from the left. So for this limit, we have 4x over with x squared minus 4. So same thing, the technique is the same. It's just like what you do here. So you're putting negative 2 here, you're getting a negative number. Negative 2, imagine this is a negative 2, 4 times negative 2, you get negative number. You put negative 2 here, negative 2 square, you're getting 4. 4 minus 4, you're getting 0. It's a number divided by 0, you are getting infinity. Okay, same thing also, you need to check for the left. To the left of negative 2. For this value, you have to check to the left, to the right, right? So 4x, for this function, what happened? So it's the same, you are getting infinity. Why? Because this is the case of a number over 0, where you put negative 2, negative 8 is a number. You put negative 2 here, you get 4 minus 4, you're getting 0, a number and 0. So when the limit of this type of case, you are getting infinity. So the problem is the sign here, right? How to decide the sign here? Very simple. Okay. As you just now, you directly substitute here, you get negative 8, right? You get negative number if you substitute. Okay, negative. This one also, you put negative 2 inside here, you're getting negative 8. Okay, both negative. But this is the kingmaker, right? This is the kingmaker of the sign for this. So negative 2 plus, choosing a number slightly more than negative 2. Negative 1, right? Negative 1. So imagine that if you put negative 1 inside here, imagine that negative 1. So you're getting 1. 1 minus 4. 1 minus 4. You're getting negative. So then you know that this is a negative. Then this is also negative, so you are getting positive. Alright? You are getting positive. And this one also. So you have negative 2 minus. This one means what? To the left, slightly to the left of negative 2 means smaller than negative 2. Alright? Smaller than negative 2 must be negative 3, right? Negative 3 is smaller than negative 2. So I choose negative 3, is near to negative 2. So negative 3 square. Imagine that x is negative 3 squared minus 4. You are getting 9 minus 4, 5. Okay, doesn't matter. As long as the number is positive, you record here as positive. So negative, positive, you have negative. Now you see, limit of this, the value negative 2 here, you are getting to infinity. Either one side going to infinity, x equals to negative 2 is already considered as vertical asymptote. So this is a vertical asymptotes. Okay, asymptote means x2 and x equals to negative 2 are the vertical asymptotes. Alright, so now go for the horizontal asymptotes. So the procedure is you finding the vertical asymptote, then you finding for the horizontal asymptote. So horizontal asymptote is we evaluate the limits at infinity, limits of the positive infinity and limits of the negative infinity. This is the standard procedure. So for vertical asymptote, we look at the denominator, then we equate it to 0, then we get the two value. Each value we check for the right and left. For this value, right and left. But for this horizontal asymptote, we go for the limit at the infinity, positive infinity and negative infinity. Okay, for this function, for this value of y, so it will be x squared minus 4, right? X squared minus 4. So, what's the technique of evaluate this type of limits? You put infinity, 4 times infinity, wow, very big number. You put infinity, infinity square, very big. You go and square, even bigger, right? Minus 4 is still very big. So, this type of limits is called indeterminate. You don't know what will happen, right? So, you need a technique. So, the technique that I teach during 8.1, I will divide everything by the highest power of the denominator, which x squared over x squared minus 4 over x squared, 4x over x squared. Then you are getting limits. This one you are getting 4 over x, right? X. So you are getting 1 minus with 4 over x squared. Alright, imagine that this is a very big number. Very big number. A small number divided a very big number. So approaching 0. Right? This is also approaching 0. So this whole thing is approaching 0. Because 0 divided by 1 minus 0, you have 0. So you're getting approaching 0 here. Alright? So, for limits x approaching negative infinity, the thing is the same. Right? For this function, 4x over x squared minus 4. Right? So, limits as x approaching negative infinity, the technique is the same. You divide by x to the power of 2. So you will get 4 over x over 1 minus 4 over x to the power of 2. If you evaluate, you are still getting approaching 0, and you are getting 0 over 1, you are getting 0. Right? So means that the limits of positive infinity and negative infinity is approaching to the value, the y value, this whole thing, the y value is approaching 0. Right? So it means y equals to 0, or the x-axis is your vertical, is a horizontal asymptote. It's a horizontal asymptote. So I have already know that my vertical asymptote, I have 2, and I have a horizontal asymptote. Okay, but you have a question mark, right? You have question mark. Why we study asymptote, right? What is the use of asymptote, right? So why we need to do all this type of thing to know that this is vertical, this is horizontal? Actually, along the way when you do the limits, you know how the graph move. Alright, let's see, I teach you how to using all this information here to sketching a beautiful graph. Alright, in this section, I'm going to teach you how to sketch the graph by using all the information here. Alright, so okay, of course you need axis, y-axis and x-axis. So you have 0, origin. So locating, put all the asymptote onto the graph. So where is it? You have 2 and negative 2. You have 2 as vertical asymptotes, and negative 2 also is a vertical asymptote. Alright, I locate the vertical asymptote. Now horizontal asymptote, from the limit when you're doing, you are know only so this is a y equals to 0, x-axis y. So this is the asymptote, right? This is the asymptotes. So now, what is this, right? What is the meaning here? So you look at this. You have 2, right? Let's go for 2. Now we look at this line. Line x equals to 2. So x equals to 2. You have right, you have left. Right, 2 plus, you have left. right? Right of 2 means slightly to the right of 2, not very far, very near to 2, but to the right. So you look at, it's going to positive infinity, means going up very high above. So when you go to 2 plus the value of y, when you're going 2 plus, when the x near to, we said near to 2 plus, to the right of 2, so the value of y going to very big value of y, so the y will be going very big. Okay, I just put here. Alright, I know, oh, very big. Okay, but it's actually more than this. Okay, so to the left, to the left of 2, so you're getting negative infinity. Where's negative? Very small, very big negative number. So I just plotting here. Okay, I just plotting here. So it means that the graph will going here. So how about now? Okay, now this one done. Okay, done for 2, done. So how about negative 2, right? Negative 2 to the right, positive infinity. To the right of this, positive. So we're going positive infinity, right? Going positive infinity. And for negative 2 to the left of negative 2, you're getting negative infinity, right? Negative infinity. So, alright. Then later, I go for the horizontal asymptotes. Horizontal asymptotes means that what should I do, right? What should I do? So you look at these two. How we going to join these 2 points, right? So there must be a y-intercept here, right? Y-intercept here. So y-intercept, x is 0, right? X is equal 0. So what is the value of y, right? 4 times with 0 over with 0 power of 2 minus 4. So you're getting 0 divided by negative 4, you're getting 0. Means that this graph will passing to origin as well. So now if I joining these two, I will getting a curve, something looking like this way. I will looking like this way. So that's the only way I can join in this. And for this, you want to approaching, when they said approaching positive infinity, when they go to very far away from the positive value, x positive infinity means the x very big. The x value here very big. So the graph here will be near to the line y equals to 0, but never touch. Alright? So for this one, it will be going up. Because why? Because they need to approach the line y equals to 0. As negative infinity, getting more negative, the graph will be near to the line y equals to 0. So this is the line y equals to 0, right? So this is the graph for this function. Alright, this is the graph for this function. So as you know that you have not you are only using the concept of asymptote in sketching this graph. Actually, there are more knowledge about to sketching a perfect graph. There is an inflection point here. Alright, there is an inflection point here. So that's why but I know it look like this way, because this is the way we joining these 3 points, right? So that they were going positive infinity, they were going negative infinity. Alright, so they are it's a curve. Alright, it's actually a curve. So this is the graph for this function.